In lesson 15.4, we're going to be exploring the idea of independence. We talked a little bit about independence in an earlier chapter when we looked at something called the hot hand, or winning streaks or losing streaks. In chapter 15, we're going to look at it a little bit differently. And the example that we're going to look at today involves shooting free throws. We know that in basketball, it's pretty common that a player has to shoot 2 free throws in a row. And up until now, we sort of assumed that each free throw shot was independent, which means the chance of making it is the same on every shot. And at the end of chapter 14, we looked at a case with an NCAA Final Four game where the player had to shoot 3 free throws in a row. And we assumed that his probability of making it was 82% on every shot. Realistically, we know that that's generally not the case, because if a player misses their first shot, they might get a little bit rattled and kind of nervous, and maybe their chance of making the next one actually goes down. So we're going to look at that case where Mrs. Soto thinks that she's a pretty good free throw shooter under pressure, and we want to know if her stats support this. So the table shows how Mrs. Soto performed on her second free throw shot when she was shooting 2 consecutive free throws in a row. So we have this data separated by whether or not I made the first shot or not, and then whether I made the second shot or not. We're going to start by filling in all of those probabilities. So notice that we had 50 pairs of shots that we attempted there. Question A says, what percentage of the second shot free throws did I make? Well, I made 30 of the second shot free throws, and I attempted 50 altogether. So 30 out of 50 would be 60%. Now we're going to look at some conditional probabilities. In letter B, for example, it says, if Mrs. Soto makes the first shot, what is the probability that she also makes the second shot? So now, instead of looking at the entire table, we're only looking at the case where she made the first shot. So we are essentially looking at just this row in the table. And that would be out of 40. And notice that I made 28 of the 40. So we're just using that row because we're doing a conditional probability. So that probability would be 28 out of 40, which is 70%. Now, if I miss the first shot, so now we move down to the next row, the probability that I would make the second shot would be only 2 out of 10, and that's 20%. Now, as mentioned, we talked about earlier how we think it's harder to make the second shot if you miss the first one, maybe due to added pressure or nerves. Do you think, based on these statistics, that Mrs. Soto is affected by this pressure? I would say definitely yes. So notice when we look at these conditional probabilities, it kind of shows that when I made the first shot, my chance of making the second one went up to 70%. If I missed the first shot, my probability of making the second one went down to 20%. So there definitely is a difference between those probabilities based on what happened with the first shot. Now in chapter 3, which is where we looked at streaks, we said that the outcome of an athletic performance is independent if an athlete's ability to be successful does not depend on previous performances. So the idea of what it means to be independent is still the same. We just can check it in a little bit different way with our two-way table. So let's suppose now that I don't choke under pressure and my shots are independent. And overall, I'm a 60% free throw shooter, right? We figured out overall that I made 30 out of the 50 second shots, which is 60%. So if my shots are independent, what this means is that I should make 60% of my second shots, whether I make the first shot or not. What we're going to do then is we're going to take that same two-way table. And notice here, I've got the total number of attempts filled in, but what we're going to do is we're going to change the distribution of makes and misses to reflect the fact that I'm an independent shooter. So again, remember, overall, I made 30 out of 50 of these second shots, which is where the 60% free throw shooter comes from. So we'll put 60% off to the side. Now, if my attempts are independent, that means that I should make 60%, whether I make the first one or I miss the first one. So I would make 60% of these shots, and I would make 60% of these shots, right? It should be 60% for each. Well, 60% of 40, or 0.6 times 40, would mean that I would make 24 shots. And 60% of 10 means that I would make 10 shots. Notice 24 plus 6 does in fact add up to 30. Now I can find the rest of the values by doing some subtraction. That's probably the easiest way to do it. So if I take, for example, 40 minus the 24, that means that I would miss 16 shots. 10 minus 6 would leave me with 4. Notice 16 plus 4 does in fact add up to 20, and all the totals and everything work out just the way they should. So now let's look at some probabilities. The probability that I make the second shot, we already know is 30 out of 50. The probability that I make the second shot given that I made the first one, now that would be 24 out of 40. Again, because we're just using the first row because I made the first shot. The probability that I make the second shot given that I missed the first one would be 6 out of 10. And I can compare those easily by changing them all to decimals. And notice that they all work out to be 0.6, which is what we would want to happen. This illustrates, by the way, that these events are independent. And what it means for two events A and B to be independent is that the probability of event A is equal to the probability of A given B. In other words, the probability of event A stays the same whether event B happens or not. Let's look at one more example. Here we're going to look at a volleyball match. And during this volleyball match, a coach records the outcomes of each point and whether her team was serving or receiving the serve. The two-way table summarizes those results. We want to know if the events won the point and served the ball are independent. Well, our two events are won the point and served the ball. So we wonder if winning the point depends on whether they served or not. So what we can calculate is the probability that they win the point or won the point, and also calculate the probability that they win given that they serve the ball. Well, to find the first one, the probability that they win, we take the total number of wins out of the total number of points attempted, so 61 out of 105. For win given that they served, we're only looking at this column, right? And they served 60 times and they won 41 of those points. So for that probability, that would be 41 out of 60. And what we want to know is, are those fractions equal to each other? The best way to compare them, since they have uncommon denominators, is to change them into decimals. So if they have a 58.1% chance of winning the point, if they are serving, their chance of winning is 0.683. So them serving made the probability of winning the point go up. Therefore, these events are not independent because serving increases the chance of winning. Please do the 15.4 homework in your assignment packet.